Okay, guys, today we're doing 3.3, the power rule. Let's get started. Okay, first thing, warm up. What do you write down if it is asking for the average rate of change, to estimate the derivative, to estimate the instantaneous rate of change, or the slope of a secant line? Okay, I'm going to try to get my pen here. I might switch things. Okay, here we go. So, remember, whenever you see any of those key terms, mostly the word average is the key word, okay? Average is the key word. You're going to be writing down f of b minus f of a all over b minus a. And you're going to be filling that in. And that's what you're going to be doing in order to figure out any of that stuff. Okay, what is the definition of a derivative? That's what we did yesterday. The limit as h approaches 0 of f of x plus h minus f of x all over h. Yeah, that's a x right there. Okay. What does a derivative find? Okay, remember the one-word definition, just a real quick idea, is it finds the slope. Okay, it finds the slope at any point. Now, the actual definition here is it finds the slope of a tangent line. Because remember, a tangent line finds the instantaneous slope. Remember, a secant line, remember this one up here, a secant line finds the average slope. You have to have 2 points. Secant line requires 2 points, and a tangent line only requires 1 point. Okay, and that's the whole point of calculus, is finding the slope of tangent lines using this guy right here. But today we're going to learn the first shortcut to that. Okay, so let's go forward and start it up. Okay, what is the slope of a tangent line of the function y equals 5? Okay, so let's first think about the function y equals 5. Let's do a graph of it. That's going to be 1, 2, 3, 4, 5. It's going to look straight across there. And it's saying, what is the slope of the tangent line? Well, I hope you know what the slope of that is. The slope is always 0. Yeah? Now, if it says find the slope of a tangent line, remember that's hinting at you that you should be doing this. The limit as h approaches 0 of f of x plus h minus f of x all over h. Okay? And I should be doing that for this function, but come on, guys, it's easy. I know what y equals 5 looks like. I don't need to do that function. So the slope is 0. This takes us to our first rule of derivatives, okay? Bring us to rule 1. The derivative of any constant is 0. So any number that doesn't have an x value at the end of it or anything, the derivative of that is 0. So the derivative of this, y prime, is equal to 0. If I said y equals 20, and I said, what's the derivative? Well, the slope is always 0 because it's just a constant line, in this case, at the number 20. So let's do a couple of these. Should be easy. Okay, find the derivative of each of the following functions. Well, this is a constant line. It's a constant. So y prime is equal to 0. This one, 5 pi. Okay, pi, remember, that is not a variable. That is a number. Okay, it's 3.1415926 something. I can't remember up to that. But it's that number times 5. It's just a constant. So y prime is equal to 0. Has a slope of 0. Same thing here. The derivative of negative 12 is 0. Okay, so find the derivative of this. Now we're going to have to go, that one's not so easy. Okay, so we're actually going to have to do our function here. Our limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so here I'll keep the same organization skills I have been. I'll do brackets around that, parentheses around this. Okay, so we're going to have the limit as h approaches 0 brackets for my f of x plus h. So I'm plugging in x plus h right there. So x plus h squared, and that's the whole function, so I'm going to end my bracket, minus parentheses for the f of x. Oh, this is the whole f of x. That's the whole function. So x squared all over h. Okay, well I can't plug in 0 yet because I would have division by 0 on the bottom. And remember what this is. This means x plus h times x plus h. And when you FOIL that out, you get x squared plus 2xh plus h squared. That's that whole first portion here. And if you don't know what I'm talking about, go back to the last PowerPoint that I did. But remember, all it is because I'm FOILing that out. And x plus h squared, that just means x plus h times x plus h. And when you FOIL this, multiply all your stuff, you FOIL it, you get this, okay? Minus x squared, all divided by h. Okay, well, we also, I forgot to write this, the limit as h approaches 0. That's an important thing not to forget to write, like I just did. I still can't plug in 0 because I would still have division by 0. So we need to cancel some stuff out here. Look at this, x squared and negative x squared cancel each other out, leaving us with the limit as h approaches 0 of 2xh plus h squared all over h. You notice there's h's in all these, so let's factor an h out. So we got the limit as h approaches 0 of factoring out an h here. So I only have 2x left there plus h all over h. Cancels the h's out, yeah? And we're left with the limit as h approaches 0 of 2x plus h. Now we can plug in 0, and we get 2x plus 0, which is just 2x. Okay. So, what we're going to try to do here is I want to use this. This is the derivative, right, of that, to kind of see a shortcut here. If you notice, what they're doing is they're taking that exponent right there, okay? They're moving it down to be the coefficient. So we got a coefficient of 2 now, and they're subtracting 1 from the exponent. So let's do this with maybe a problem that's a little bit longer. Let's do y equals x to the 4th. Now, doing this, x to the 4th with this long method would take forever because you'd have to FOIL out x plus h to the 4th. You'd be doing that for 10 minutes. But let's use this little shortcut that we just noticed here. You bring your exponent, you bring it to the front. So here's what y prime is going to be, is the derivative. We're going to bring the exponent to the front. That's going to give us 4. Then we're going to subtract 1 from the exponent. X to the 3rd power. And there's the shortcut right there. That's the first shortcut you guys are going to learn for derivatives. It's called the power rule. Okay? So this is the power rule. And that is rule number 1 for y'all. That's going to become so common for you that you're not even going to think it's a rule. You're just going to think that's how you take a derivative. Okay, let's go forward. So, I'm sorry, that would have been rule number 2. Our first rule was that the derivative of all constants are 0. So rule number 2 is the power rule. Okay, here's the mathematical way of writing it out. You bring this is your original function, x to the n. You bring the n as your coefficient, and you subtract 1 from the exponent. Okay, so it looks like we just did that one on the other slide. So why don't you guys try this one, x cubed. the derivative would be 3x squared. Yeah? And here, let's switch this one up. Let's make it a 5 or a 6, since we did x to the 4th on the last slide. So the derivative of that would be 6 x to the 5th. Yeah? Now these are easy ones. They can make them hard. Let me show you. Oh, and I can show you how to do it on a calculator. I'll do it later though. Okay, these are where they get a little more difficult. Okay, on this power rule, first thing, you got to remember, you always got to write it as a power. So I'm going to rewrite this so it has a power on it. Remember, a square root means x to the half. Yeah? Same thing here. Now over here, it has a power, but I want it to be on the numerator. Okay, that's just one of the rules for this shortcut, is you got to write it so your exponent is on the numerator. X to the negative 3. Okay, those two are now rewritten so I can do the power rule. So let's do it. So I bring this down to be the coefficient. Okay, so that's my new coefficient. Now I put x to the, I subtract 1 from this. Now this is where people are really bad at the start. I'm subtracting 1 from the exponent here. What is a half minus 1? Well, remember, you got to have a common denominator. That means we need to have 2 over 2. 1 minus 2, negative 1. You keep the common denominator. It's a negative half. So that's our new exponent, is a negative half. Okay? Now just an easy way to remember how to do that, just do 1 minus the denominator. Just do numerator minus denominator, and that'll give it to you. 1 minus 2 is negative 1. Negative 1 over, keep your denominator. Okay, and then that is your answer right here, except remember, in calculus and mathematics, you never want a negative exponent in your final answer. So I need to move this thing. Right now, all that stuff is on top. I want to take it and I want to move it to the bottom. And that will make the exponent positive. So now I have 1 over 2 x to the half. And what is a half exponent? Remember, we just told you what that was. A half exponent means square root. So 1 over 2 square root of x. That's the answer to that one. Now let's do one that's kind of similar. Here, I'll make another one right here. Y equals, let's say, cube root of x. Okay? I don't know, maybe even to make it harder, let's do x squared. Okay, you would rewrite this one as x to the 2 over 3. Yeah, that's going to be your numerator. That's going to be your denominator. Okay, so if we were taking the derivative of this, you would bring down the exponent. That's going to be your coefficient. I usually put a long line because I'm going to write the x value on top here. X to the, okay, we're subtracting 1 from here. So you can do that on the side. Minus 1, right? Which is the same as 2 over 3 minus 3 over 3, which is going to be 2 minus 3 is negative 1 over 3. Okay, that's my new exponent. Or remember, what you could have done is that shortcut idea I just showed you. 2 minus 3 is negative 1 divided by, keep the denominator. Okay, there we go. Can't keep that negative exponent. So we're going to have 2 over 3x to the 1/3. And remember, 1/3, that's the same as cube root. 2 over 3 cube root of x. That's a 3 right there for the cube root. That would be your derivative right there. Okay, this one's going to be easier here. Okay, we're going to take the derivative of it. We've already moved it to the top, so everything's on the numerator. We bring down the negative 3. X to the, subtract 1. Negative 3 minus 1 makes it a larger negative. Negative 3 minus 1 makes it negative 4. Okay, well, we don't like negative exponents, so we're going to take that number, we're going to move it to the bottom of the fraction. Remember, That's going to make it a positive exponent. So negative 3 over x to the fourth. And there's your derivative right there. So now you know the power rule. Okay, let's just do one with an example here. Find the instantaneous rate of change of the function v of t at 2. Okay, so I want to, remember, instantaneous rate of change, that means derivative. So I want to find the derivative of this thing. Well, I can't leave it like this. I need it to be written as an exponent. So t to the half. Remember, I need everything written on the numerator, just like we were doing in the last thing. So that means I move it to the top, and now it's going to be negative. Okay, there it is rewritten. Now I can take the derivative of v. Okay, bring the thing to the front. Negative 1 over 2. Okay, t to the, I subtract 1. Now remember that if you're using my little shortcut, negative 1 minus 2 is negative 3. Keep the denominator 2. Now if you're not using my shortcut, we're doing negative half minus 1. That's the exponent minus 1. Well, we need to find a common denominator. Negative 1 minus 2, negative 3 over 2. Okay, and that's what your new exponent is. Now, I can't keep that negative exponent, so I'm going to take everything here. I'm going to move it to the bottom. So on the top, I'm going to keep that negative 1 over 2 t to the 3 over 2. Also, I don't like this being written like that. So I'm going to rewrite it one more time. It's going to be 2 square root, that square root's coming from the division by 2, t cubed. Okay, that's the derivative. That is the instantaneous rate of change. Now it wants us to find it at 2, though. So let's go over here. We're going to find v prime of 2. That means the instantaneous rate of change at 2. We're just going to plug it in. Negative 1 over 2 square root of 2 cubed. Okay. Well, let's work it out here. See if it comes out to be a nice number or not. Negative 1 over 2 cubed is 8. So 2 square root of 8. Well, this is not going to be a nice number because I don't know the square root of 8 is. But I can break this up. So we're going back to your middle school math here. 2 times square root of 4 times square root of 2. Remember, I broke up the square root of 8, so that's going to be 4 times 2 is 8. I know what the square root of 4 is. That's why I did that. Negative 1 over, this is 2. So I got 2 times 2, which is 4 square root of 2. And that's going to be as simplified as I can make it. So that is the instantaneous rate of change at 2. I believe that's everything.